Test, test. All right, so this is about my second or third attempt today. This is my first time streaming, so I'm kind of getting just started. Hey, first of all, I wanted to introduce everybody to the project. I guess there's like, oh, it looks like there's somebody watching. Excellent. I want to introduce everybody to the project and tell you why I'm doing this. The purpose of this video or this series of streams is going to be just show how I would remix a 3D printer that I found on Thingiverse. Now the reason that we're doing this is, you can see right here I'm on this website. This is the Yakima Maker Space. It's my hometown. We have a non-profit Yakima Maker Space. There's some dudes I know down there. I run the 3D printers down there and bring a bunch of RepRap, which are like these open source build your own 3D printers down there. There's a bunch of dudes who are members down there who got together and they keep talking about making a printer. So what we're going to do is we got together last week and we decided, hey man, let's pick one. And what we talked about at first, they had seen my MicroWrap 200 that I brought down there. Now this is a printer that I designed entirely myself, and these guys wanted to. They had expressed interest in making one of these, and I also had one of these, so they've seen the MicroWrap 100 that I designed. But the thing is, I kind of try to steer these guys away from it because for their first printer that they're ever going to make, we want lots of options for them to upgrade it. And as much as it would be flattering for them to make the one that I designed, it'd probably be much, much better for them to have something, you know, like, look, I don't have any remixes. I think I have one remix on this one. Yeah. But the thing is if you look at something like this, so I showed him the Hypercube Evolution, and even though I would like to build mine, I steered him towards this. And the reason is because one, I want to have fun doing this too, and I have never built a Core XY printer. That's what I'm going to do here. And the other, I would say the other reason that I'm steering them towards this is look at the number of remixes, right? There's 276 remixes for this, and the original version that the Hypercube came from by Tech2C, that has a ton of remixes, probably even more. So this gives them, because I remember my first printer, you know, I wanted to swap things in and out. This gives them the option to do that. So essentially what I've done here already is I've clicked download all files. I can do that again, why not? I've downloaded this and unzipped it. So these are all the files for the Hypercube Evolution. And so what I'm going to be doing here, here's the purpose of this remix. The whole reason why we're doing it is at the Makerspace, we have a CNC machine. So instead, if you notice on the Hypercube Evolution, it's made with these 2020 aluminum profiles. Or no, I'm sorry, 3030. Actually, the bed uses 2020. So why fuss with that when you have a full-size, super accurate, awesome Shopbot? Like it's a CNC machine. We have that at the Makerspace. So what I'm going to be doing essentially is I'm going to take Scott 3D, his design here, and I'm going to remix it so it doesn't use the aluminum extrusions and instead uses a wooden CNC frame or whatever. You know, you could cut it out of aluminum, any sort of material you want that can be cut on the CNC machine. So essentially what you can learn from this series, I'm hoping, is that how to go about the beginnings of remixing someone else's printer, or maybe from what you learn from this, you'll be able to just design your own printer outright. But essentially there's all kinds of opportunities where you come across where it's like, oh, I would make that if it was just this or that. So that's what this will do. Now, the way I like to start out doing this is SketchUp. And the reason is SketchUp, I'm not going to do it. This is just kind of think about it. I do the rough draft in SketchUp only. That's what I say. And then once we get making the actual parts for this printer that I need to make to modify it, I'm going to be going into a different program. I'm going to do Onshape or maybe Fusion 360. But for now, this is a great program. SketchUp's a great program for like playing around and seeing how things fit together. And also, here's another thing you can do with SketchUp that's very easy to do that other programs, even though they're more powerful, can't really compete with. SketchUp is awesome for building your first printer. And what I mean by that is that like you need to, before you start modifying someone else's printer, you need to have at least built it. And if you haven't built it yet, that's a problem. So you can use SketchUp and import STLs and actually build your own 3D printer in SketchUp. Move the parts around on the axes and see how they interact with it. Are they going to run into something? Whatever. You can do all that in SketchUp very, very well. That's where we're going to start with this video. Is I'm going to start making the mock-up of the Hypercube Evolution. The part that I'm actually going to have the same on my machine, and that is going to be the X gantry. That part is going to be completely the same as the original design by Scott 3D. All right, so what I've done is I've opened SketchUp and I used, I think the template I used was 3D printing and millimeter. That's the template that I used. So let's take a look here. First of all, I'm going to go to model info, and I don't fade. I like to have it so I can see stuff outside of the group when I'm working inside of a group or a component. And another thing I'm going to do is units. Is we're going to change this to you know, this is a little ridiculous. You don't need that type of precision. I think 100th of a millimeter is plenty for what we're doing. Being as we're not, like I said, we're not producing parts on this anyways, so we're just going to use it to mock up. And the reason we wouldn't use this for parts, by the way, is, well, it's not too bad for flat stuff if you're making CNC parts, but man, I'll tell you, like the Boolean tools in this do not really work. They don't make watertight models that we can use for STLs and stuff like that. So that's one reason why SketchUp is good for you know, kind of playing around with, but probably not my favorite for making finished parts. Although for basic stuff, it works fairly well. All right, so let's go ahead and go to File, and we'll start importing. And I'll go to Downloads. And there it is. You know what? I'm going to just kind of link this right up here. All right, and we go to Files, and we need to change this to an STL file. Hey man, this is really important if you're going to play around with this. Merge coplanar faces. It'll cut down on the number of triangles that it has to deal with. And then make sure you change it to millimeters on the export. So I was under options. Merge coplanar faces makes it way better to deal with imported STLs. Just basically all these little thousands of triangles that make up one flat surface, it just kind of combines those together, no problem. All right, and next up here, I'm going to just go ahead and let's start off with the basic, the X carriage. Let's find that. X carriage is a thing that slides back and forth that we mount the hot end on. All right, let's use L for line, and let's check by referencing this just to make sure that the import worked right. Yep, 55 millimeters, that's correct. All right, so in this one, I'm going to rotate by holding down. Now, in SketchUp, if you're just starting with this, man, these arrow keys are so important. See, there are these axes. Okay, you got the green axis. If I want to rotate it around that, I press the left button. Anything to do with green is the left arrow. All right. If I want to see this blue axis going up, okay. If I press the up arrow, I lock to that, and I would be rotating around that. And what I want to do though is this red axis, the X axis here. I'm going to press the right arrow, and then it locks my rotation into that. Yep. And let's just go start it. And then what you do is you start it in the direction, just type in 90, enter. Whoops, that's actually the wrong way. Sorry. Let's try that again. 90. Okay. So, no, I did have it right the first time. Now I think about it. Whoops. So let's try that again. Whoops. Okay, now I'm going to move this down a bit because I really need to be able to reference that origin. And by the way, man, if you see me doing something that's kind of amateur mode on SketchUp, you're absolutely right. I'm kind of a SketchUp amateur. I've used it quite a bit where I try and get fairly fast at it, but there's a lot of stuff that every time I see me watch a video on it, I learn something new that I've been completely missing in the past. All right, so now let's grab, well, they call it the extruder mount. As a misnomer, really. The extruder is what the motor and the driver gear has to do with. This is actually, since it's a Bowden setup, this is actually a hot end mount. So it's not really an extruder mount. Let's go ahead and rotate that. Make sure we're locked on the red. 90 degrees. Okay, and same thing. If you want to move it and lock it, move it only in the green direction, press left while you're moving it. As far as like how to do this quickly, practice makes perfect. That's all I would say. Okay, you know what? Those are lined up just right. So see, what I do is I just try to basically do everything that I can in this program and just kind of build whatever I can virtually. in a sense, so I can build the stuff that I'm going to replace around it and get an idea of how things fit together and how that works. Okay, so now I want to, you know what I want to do? I want to put in a nice looking LM8UU bearing. Okay, so what I'm going to do is I'm going to actually, if you're looking for parts, what I would always do, like parts like you know, pulleys and stepper motors, stuff like that, hot ends, always check the 3D warehouse instead of doing the STL import. It's actually kind of better, and it'll work better in your model in here. So I'm going to go up here, and I'm going to go to the 3D warehouse. Where'd it go? There it is. You may have to log in. I can't remember. There's a way. There's something like that. And we're just going to LM8UU. It's the type of linear bearing that we're going to use. All right, here it is. Bearing LM8UU. Looks good. Whoops. You know what? I just completely messed that up. Okay, download. And it says, do you want to put it in your sketch? Yep, that's where I'm going to put it. So let's put it right in there. And here it is. I'm going to set it right here. Q for rotate. And then I want to rotate it around this green axis. So I press the left arrow. And there we go, 90. That's fine. Now what I need to do is I'm going to actually make some rods. Now the rods I want to make for this, ooh, it's got that line in there. You know what? That's actually pretty useful for what I want to do. So I'm going to actually leave that there, even though it's a bit annoying. So I'm going to make a circle, and I'm going to lock it around the red axis, see? So it kind of like wraps on that. And just for now, we could do it right here. It doesn't really matter. And remember, I'm going to put in a radius of 4. And what I'm making is the rod, something to fill in like a mock rod. And that's 500 millimeters if you're going to go with a big old 300 millimeter version of the Hypercube. And I'm going to double click on that, or triple click, I can't remember which one I did. And I'm going to make it a component. 8 millimeter rod. I don't know, I don't ever use those labels, but let's just do it. So it looks like I know what I'm doing. Okay, now on this, I just know this, the same on the Prusa, the offset here between this center to center offset on these bearings is going to be 45 millimeters. So let's just go ahead and, first of all, move this one back to the middle, 250, which is half the distance, so it's right in the middle where it's going to eventually end up. And let's move this one up, and I'm going to hold down Control to make a copy, and up 22.5, which is half of 45. And this other one, I'm going to move down 22.5, and let's just, I like to, I don't know, just double check that. Hold down the blue, or excuse me, press the, excuse me, and yep, looks all right, 45. Okay, so now what I'm going to do here is I'm going to move this bearing up till its center is, that's a problem. I can never seem to reference the middle, and I don't know, maybe I'm just not that good. There we go. And we'll do another move to line it up in this other direction. There's a center reference and right, or excuse me, left. Smack dab in the middle. Yeah, that looks great. All right. Now I'm going to move it over until it's up against the edge of this thing. So it's even with the edge of this. I'm going to hold down Control, or press Control. Press the right arrow and move it over. I didn't do it right. I want to reference this edge. Let's try that first, again, and move it. And I'm going to move it over to the edge of this guy, right there. Okay, now we need the same thing. This is pretty easy. You just have to hold down Shift, grab both of those. Blue arrow to lock it into a straight up and down motion. Press Control once. We got a copy, and we're going to type in 45. There we go. So basically, this is an awesome way that you can build any printer before you build it, or you can build any printer before you actually in reality build it. All right, now this gets a little tricky. Now I'm going to show you, this is pretty important. Parallel projection really helps for lining stuff up. It gets rid of the 3D perspective that's involved. And I'm going to go right here to the end. Okay, get a right view. Oh, another thing, when you get in here, go to right click somewhere in the empty space on these in this area. Right click and turn on views, and you can get all the different views with the exception of bottom. They don't have that one. So All right, so I'm gonna hold down Shift. Let's just start making a component for the, let's just group these together so they don't come apart now that we've got them. And I'm gonna just kind of, basically, I'm gonna try to reference, I'm not gonna worry too much about it, but I don't know, for some reason I just can't. You know, actually this might be easier to just go right in the middle, because I'm sure this is symmetric. So I'm just gonna go right in the middle, reference that, go up until we get to the origin. That puts it right there. That's actually easier, I think, than the way I was planning to do it. And now, get another exact right view. You see, when I turn the perspective off, man, I can really get in here. That looks close enough. I don't know if that's exactly right, but it should be. Yeah, I mean, that's good enough for just a mock-up model. All right, so there's a group. I'm going to add these bearings to that group. And just make it a group. But see, now there's a subgroup in there that's kind of stacked up that makes it kind of a mess. I'm just going to go inside there, double-click it, and explode it. Yeah, there we go. Now let's see if this all moves together. Yeah, okay. All right, we're starting to get a little bit of a group. You know what? Probably I should put on the clamp here. Just a moment. I'm going to go grab some water. Just a second. It'll just take me like 1 minute. Okay. All right, I'm back. So, all right, so I need to put the little clamp on here, and then this is for an inductive proximity sensor, which it's the Evolution uses for G29 type auto leveling. Well, that's the G code for it. All right, so you know what? The problem is that this is going to start importing stuff right here. So let's grab the stuff and move it down. So it's kind of out of the way there. And I'm going to go File, Import. I think it's called the retainer. Yeah, that's it. All right, and let's see. So this retainer, we need to rotate it around red, I think. That's one way we need to rotate it. Okay. And also around the middle, green, 180. Flip that upside down just so that you can see, so that groove matches up with this groove over here. And here we go. Hey, big ups to whoever's watching me, man. I appreciate having somebody. My first live stream. Man, I hope the audio is actually working this time as opposed to earlier today. Earlier at 11 Pacific, I tried streaming. Not good. But that was my second attempt at it. And that time, the only problem, at least, it was a good problem. It was an easy problem. So I just didn't. I didn't click this little. This was turned off on my microphone. So I went like 30 minutes straight before I finally looked at the chat message and my friend had been watching, and I didn't notice. He said, "Yeah, I can't hear you." So I just stopped after 30 minutes. So I've done all this already once today. All right, I'm kind of getting off track, so let's do this. Let's make an inductive a filler for the inductive proximity sensor, excuse me. And we will push this down. And hey, and you know, you got to really remember in here, oops, that when you make your circles, it uses radius, not diameter, this program, for the most part, I think. Man, I don't even remember how big these are. I think they're like 60 millimeters. Whatever, I'm not going to take time to look that up. I have one out in the garage, but I don't want to get out of there, so. All right, and let's move this guy over here. We'll get a top view. That's kind of close. Yep. That, and that's a bad job. No, you know, it doesn't really matter, but you know what? If it's worth doing. I'm just going to eyeball this. I mean, usually I would reference something here, but that's pretty good. Okay, that's about as good as I need to get it. We need a hot end too. Let's throw a hot end on there just so we can see that. And I know that there's a good one in the 3D warehouse for the E3D V6, which is a very popular one, and that's what the Hypercube Evolution uses on this version. So I'm just typing in E3D V6. There's this one where it has two at the same time, and I'm just going to click this button, and it kind of just throws them right into the model. So you can see already, man, any 3D printer that you find on the internet, if you're new or you're just like, hey man, I don't know if I want to make this, or, you know, you can get really familiar with it before you spend all the money and do all those things. And then guess what? Afterwards, when you have this file made, it has value, because now whenever you want to modify or make something for it, an enclosure or, you know, who knows what, right? It's not hard to do that at all, because you already have a mock-up of the whole thing ready to go. Let's explode. Just kind of turn those guys around. You know, this is so annoying having this tube out of there. The last time I vowed I was just done with it. Oh, actually, you know what? I will have a Bowden tube going out of there. Why not? What I'll do instead is I'll just go get inside this group. I'm going to make a line, because this is going to be useful later on, because we're going to be referencing this. This is the most important point in the whole printer, right? Everything focuses all around that point, in my opinion. And let's make that go up, let's say 200, because it's so important. So I can always reference that with other stuff when I'm measuring distances and moving things about, whatever. All right, so let's get that lined up with, now here's the thing. This is going to have to go, let's get a top view while we're doing that, right to the edge of that arc. Yep, that should be lined up. Get a good view, reference that again, and now we're going to lock it on the red and just do, man, that's one thing. If you're new to this program, if you really need to line stuff well, I'd say the best rule of thumb is one axis at a time. Let's flatten that out down there. One axis at a time. So I'm just moving one thing at a time. Now I'm going to get it over here. Well, that should be actually lined up right with the origin. Now I think about it, because that was centered. Yep. Now I have the hot end, and you know what? I think I'm going to call that good. Now there's an end stop over here. I don't know. Let's see if they actually have one of those in here. If not, I'm not going to worry about it. My dog is chewing on a bone over there. Pearl is just getting down on a bone. So if you hear something in the background, that's what it is. It's dog chewing on bone. It was a bone from a cowboy ribeye, which is quite the treasure for a dog, I would say. She's been working on that one for a while now. Okay, so let's try optical end stop. Wow, let's just say that. What was the other thing they had here? Okay, so it must be one in here, huh? Look at this. See, so somebody's done a whole printer. Man, you can look at stuff like this too and learn a lot from it if you're brand new at 3D printing. Well, this is a pretty old one, though. Okay, I'm not going to worry about the optical end stop switch, but we do need to put these things together. So clicking shift on the one I already made, this, and this. We're going to do that group, get inside, explode trick. Okay, there we go. Cool, that's moving together. And now from here on out, we're gonna actually nest this in a group. Actually, we'll wait, because we're gonna add a lot more to this, a considerable amount. Okay, so now we're doing pretty good. And now look, here's the version we're gonna make. We're gonna make the ones that have the 10mm y-axis rods. See if I can find that a picture to let you know what we're doing. All right, so yeah, you see there's different options. It's really cool. There are a lot of different options. You can use 8mm or 10mm for the X or the Y axis. So they have all these different options with this, because a lot of guys will use the carbon fiber rods. They'll use aluminum rods for the X axis, whatever. But for the Y axis, we're using the nice bigger 10mm rods rather than the 8. So for me, and those are the rods. Let's see if we get a better picture. I don't know. Yeah, those are the rods that kind of run along the y-axis. And then this entire x-axis here, that's kind of what I want to finish right tonight in this video. All right. Okay, so let's go ahead and let's just get rid of that for a second. And I'm going to start importing these ends here. And I can't remember what they're called. Okay. Let's see. Extruder mount. That is 3030. Yeah, probably not going to be using that. Okay, here it is. They're down here. So it's the Y carriage. So let me think what we need. We need the one that has X diameter 8 and LM 10 UU. That's the one we want. So that'll be using 8mm steel rods, or actually we might do some aluminum with some printed with IGES tribofilament, but we'll see. So, but either way, it's going to be about an 8mm rod. So I'm just going to kind of turn this direction, and it looks like that one will be going over this way. So I'll reference right here. I think this is symmetric right about that middle point. If not, we'll find out. So I'm going to go over here, and this will line up with the rods, actually. Yep. And then we need to get this thing, well, we could take probably this right in this middle point and move it down here. See, that was the middle point, right? And, can't reference it. Okay, I'm going here and make a little line real quick, an actual line that's easy to reference. There we go. And here, where is it? Let's go with the left view. There we go. Thanks for bearing with me here. This, like I said, I'm obviously an amateur streamer who doesn't know what the hell he's doing. Down there, and that would take it there, and we need to go down an additional 22.5, half of 45, which is the offset. That looks like it's lined up pretty well, but it's hard to say until we move it. Let's move this. Whoops. No. For this part, and this part's supposed to go right up against the rod here. It can overshoot a little bit if you want it to, but I want the maximum amount. And you can see that kind of clamps around there, and you tighten this screw right here. And what's kind of cool is you insert a nut, an M3 nut there, and so what that does is that would just clamp around these bar ends here. All right, so got that, and those are actually the same on both sides. So in a second, after we get this side all the way built, we will copy it to the other side. Always try to do that, man. It saves a lot of work in the long run. You know, you don't want to do things twice if you don't have to. Okay, so let's go down. And what we need now is clamp for the LM8 10UU. And that's the thing that kind of holds that bearing in there. And while I'm here, I'm going to grab an LM10UU from the 3D warehouse. These are the linear bearings that are 10mm inner diameter. LM10UU. Pearl's getting down on that bone. All right, there we go. Yep, I want to put it directly in the model. Let's throw it over here somewhere. Perfect. And there we go. So this one, first of all, needs to be rotated. Let me think. No, around the green. Yeah. 90 degrees. Oh, did I do that wrong? Yeah, I think I did. 90 this way. Yeah, it should be 250 exactly. All right, and now this one, I'm actually gonna see if I can just do this all at once. I'm gonna kind of cheat. Nope, I guess not. Oh yeah, it's already lined up like that. Okay, cool. So there's that, and let's go ahead and rotate this one locked onto the x-axis, of course, and 90 degrees. And there's my LM10UU. You know what? I think I'm gonna actually lock onto this y-axis and make the 10mm rod right now. No, nope. That's 5mm. There we go, for the radius. And I'll push that 500mm. How long that should be. Make a component. 10mm rod. Okay. 10mm rod is there, and you know, this will be handy later on. I'm almost sure there's something I'm missing, and that I shouldn't have to make little lines like this, but it just helps me out so much to reference stuff. When you're moving circles around, they can be really a pain. So I'm sure there's probably a better way to do that, but whatever. That's a good point, man. Is that if you're thinking about diving into something like this, just realize you don't have to know everything. Like you don't really have to know everything beforehand. In fact, the best way to do it, the best way to learn is out of necessity. You'll learn better like that, in my opinion. When you actually need to know something, I think you'll find that you're much quicker in being able to learn it, I would say. Whoops. So just dive in. And, hey man, SketchUp, I've got the pro version right here, but SketchUp is free, so you can do this for free, and the STL import, it's free, it comes with it. Okay, so there's one bearing kind of lined up. Let's poof this thing. Let's grab those both and move them to the middle. And actually this bearing, I need this justified against the very middle here, the origin, and I'm going to duplicate it by moving it and pressing Control when I move it, which makes a copy. You can do the same thing with the rotate tool, by the way. Whenever you're rotating or moving something or transforming it, tapping Control will make a copy of that item. Okay, so that's what I want. Now let's see, make sure these, you got to check some of these models. There's some people that model they just want to have the accurate dimensions. Okay, is that right? 56.6? I don't know about that. Yeah, let's look that up real quick, because I don't use LM10UUs that much. I don't have them. LM10UU. $29. So they would be 10 by 19 by 29. Shouldn't we be getting 58 then for the length of both of these put together? Eek. 56.6. Okay, so let's see if they even have the right diameter on this. 19.95. I'm pretty sure that's not right either. Huh. Well, you know what I'm going to do? Make some cylinders, bro. There we go. Let's make some cylinders. That's it. What were these things? LM10UU. They were supposed to be 10, 19, 29. Let's double check that with another one. 10 by 19 by 29 on Amazon. Yeah, I think that's probably safe to say. So radius of 5. Nope, sorry. 19, so we would go 9.5. For the radius, get rid of a circle in there, that's 10. Delete that circle, push this and extrude it 29 millimeters. Okay, it's not as fancy looking, but you know what? It doesn't have to be. Doesn't matter. It works. Okay, let's put that in the middle. Let's make a copy of that. Locked on green. There we go. All right, there's those. There's some beautiful LM10UUs. Maybe not, but whatever. And for now, I'm gonna actually avoid putting this in a group. Oh, sometimes when this camera screws up like this, you have to kind of switch it back to perspective, and then you can switch it back or whatever. Let's go over to here and line it up. Ugh, yuck. Shit, it moved right at the end. Whoops. Okay, there it is, and get this in the middle. What's a good middle reference point? Oh, that's a great middle reference point right there. Okay, so there we go. Yeah, it looks pretty good. And actually, I forgot, there was supposed to be, because this is a clamping, what they did is they kind of, they obviously are going to leave some out there. So let's look at this from the back. You know what? Who cares? That doesn't matter. It's only like 1/4 of a millimeter or something. By God, I'm going to move it. I think it's 0.2. Okay. All right, so there we go. We've got that. That looks good. I'm going to make a group. Let's see here. Or just grab these things. And if I remember right, these... Yeah, I think one of them gets flipped, but I can't remember. Let's see. It has to do with the way the belts work. But for now... Oh, we almost forgot. So in here, there are the belt idlers. Some of them are toothed, some of them are not. For what we're doing, they're just going to be toothed. You know what I mean? We're just going to make them into a toothed type of thing. So let's go ahead, and I'm going to look up the dimensions of those so I can draw some mock-ups for those guys. And I may have them already. Let's take a look. I think I have these in my rep. Yeah, I think I do. So grabbing dimensions is a big part too. That's another skill you really got to get good at if you're going to learn to design and modify 3D printers, is pulling up dimensions. Like search Google with the word dimensions after it, and you can find out a lot of information. And you click images, you can get a lot of dimension drawings from sites that sell these things. They'll have the little dimension drawing next to it oftentimes. Okay, so there's my parts library. Let's see if I have a 22. I do. Okay, cool. It's actually 2 drawings. There's one of them, and there's the other. All right. So no, those are the same. Oh, this is 16 tooth. Okay. So this is what we're going to be looking at here. Let's put that here. Doesn't need to be that big. That here. All right, so let's lock on to the vertical axis, so where this is straight up and down. Let me think how I'm going to make this. It's a little trickier. Okay, yeah, that's pretty easy. Okay, so I'll just make the middle part first. And I don't know, let's see, on a GT2 20 tooth, well, you can tell, let's see. Just get a rough estimate, like just, I don't know, not that it matters, but you see you just go 20 times 2, so it's 40 millimeters of diameter, and then divide it by pi. All right, it's about 12.7, whatever, close enough. 12.7, so half it, so it's 6.35 radius. And that looks enormous compared to this. It's just because it's actually not close to it. It's very close to the camera. So there it is, and we're going to push that 6.7 for the inside part, again according to this drawing here. And we can do that middle part, which is a 3 millimeter hole, so 1.5 millimeter radius. Let's push that down. Okay, and lock it on here. We'll make the top and bottom part, actually, they're both the same. Let's go out here. Now, how big is that? It's 18, so 9 millimeter radius. And we're going to, make that a group. Whoops. Let's try that again. 9 millimeter radius. Let's get rid of that same hole. 1.5. Delete that. Grab the, this piece and push it up. How thick is that? So let's see, it's 8.7, so that would mean okay, so 1 millimeter thick. Make a component, create, and we're going to move this down from here. Press Control, and back up to there. Okay, that looks good. If everything looks good, this should be 8.7. Hey, look at that, 8.7, great. Let's make a component out of that, because we're going to make many copies of this, and this is a idler. Yeah, and the difference is a pulley is actually attaches to the motor and drives it, whereas an idler is just something that returns the belt, essentially. On the other side, just kind of loops around it. Yeah, and these in particular have a little bearing in them. We could mark that up on there, but who cares, really? All right, so let's go ahead and get these in place, and then that will complete this one. We can mirror it over there, and then we'll be done with at least part 1 of this. And hey, man, if you were watching this, homework assignment, do the same thing I did. You can learn so much from this about your 3D printer before you ever build one. And you know, a lot of people out there, they bought a 3D printer, but they never have built one. And so this is a pretty good challenge, I'd say. And you can, like I said, you can learn for free. There's so much free software on the internet. This is no exception. I mean, this is definitely one of them. That looks good. Okay. I'm going to grab the middle here and go down until I'm right in the middle of here. And then move it to where it needs to be here. Top view. There we go, click. So we have one pulley in place, and you can see good designer is going to leave some wiggle room in there, and that's good, you know. All right, so that looks good. And you want to move this over, so we're going to hold down Control when we move this, or not hold down, but press Control. I keep saying that, man. So I'll just put it over here so it's close by. Let's go ahead and center it vertically with this. See, I'm referencing the midpoint here. Again, this is the strength and how awesome SketchUp is for this. Again, I have to qualify it because it's not good for other stuff, but for this, man, I'm sold, you know. All right. And we will move this. So I have to get it just right. But that's okay. You know, if you have to do a little extra to get it just right, welcome to the world of 3D printing. You are in a very, kind of a hobby that I guess doesn't require it, but it rewards accuracy and precision and working very precisely and being very detail oriented. So maybe it is good that I take a little extra time. I don't know. I'm just saying that to make myself feel better, probably. Okay, so you can see that's kind of screwed up again. And again, hey man, leave that comment. If you see me doing something repetitive that is easier to automate in here and I'm really screwing something up, I use this all the time, I would love to know about it. So please comment. And hey man, if you are in the live chat or whatever, just hey, feel free to say hi. It makes me feel better when I hear people kind of give me a little encouragement, I guess. Okay. Oh. Yeah. Okay. I see why I'm not able to grab that like that. You know what? We are going to go in here and we are deleting this extra little line here. That is not helpful. Okay. So now what I need to do is I need to really take a look at this side here. So we're going to grab this, hold down Shift, click the bearing and this thing. And what we're going to do, let's see, is that lined up? Yeah, I think it is. We are going to rotate this, and I think this is going to work, but I don't know, we'll see. Yep, 180. So I just rotated it 180 and click Control, and it made a copy all the way on the other side. Now let's take a look here, just for the fun of it, and to see, yep, that rod is perfectly lined up, and it's right there. All right. So that looks pretty good. So here we are, and oh, I probably should have copied this with it. That would have been nice. But that's easy. We just control, and that should be 500 millimeter center to center offset. Perfect. All right. So here we have essentially the x-axis is completed. All right, hey man, that's gonna conclude tonight's live stream. I think I'm gonna get back at this tomorrow or maybe Monday or Tuesday. My internet's really bad in the weather because it kind of uses wireless connection up to the ridge. And so we have some snow coming in. I'm going to try to get back to this as soon as possible. Hey man, whoever my one viewer was out there, man, thank you for watching my first ever live stream. Leave a comment. And hey man, if this taught you something, like, and maybe give me a subscribe. I don't get anything from this, really. I don't do that much, and that kind of keeps me going, man. Really do appreciate everybody out there. And so we're going to get back at this. And in the next video, we're going to start putting on some of these peripheral objects over here and finishing up everything that needs to be up at the top, and then maybe even working into the Z-axis a little bit and start reworking that, because that I'm going to completely change, because I don't know why anybody would want to piece together that 2020 for the Z-axis if they don't really have to. And with the CNC machine, we certainly don't have to. So, hey, man, again, do your homework. Give this a try. It's free. Go to SketchUp, download it. Thanks a lot.